Whenever you click play on a video, send off an email, or just buy something online, have you ever really thought about where that click goes? We kind of just assume our digital lives are, well, digital. But behind that screen, there's a very real, very physical world that's working like crazy.
That's right. Nothing just disappears into the cloud. Every single click, every byte of data, it all has to be stored and processed somewhere. They live in these massive, humming buildings that are running 24/7. You can think of them as the hidden engine rooms of our entire digital world.
So that leads to a pretty huge question, doesn't it? With literally billions of us online all the time, what's the actual energy bill for all this activity? How much power does it really take to keep the internet on?
To really get to the bottom of this, we're going to dive into a report from the folks who live and breathe this stuff, the experts at Virtualization Options LLC. They're a Colorado-based tech research and advisory group, and they've laid out not just the problems, but more importantly, the path forward. Okay, so first things first. Let's pull back the curtain and take a look at the heart of the whole operation, the physical place where the internet actually lives. They're called data centers. And look, calling them the backbone of our modern world, that's not an exaggeration. It's the simple truth. Without them, pretty much everything we rely on would just grind to a halt. I mean, seriously, just think about your day. Your online banking, all your social media feeds, the show you're going to stream tonight, even critical government services. It all runs on servers tucked away in these data centers. They have totally become the invisible but absolutely essential utility of our time.
All right, so we've established they're essential. Got it. But why are they such energy hogs? Let's take a look at the main culprits behind that massive electricity bill.
Now, this is the part that I find fascinating. You'd think most of the energy goes to the actual computers, to the servers themselves, right? But check this out. A massive chunk of it, we're talking sometimes around 40%, is used for just one thing: cooling. Just keeping all that hardware from overheating is a monumental energy challenge all by itself. A big piece of the problem is what we call legacy infrastructure. A lot of data centers are still running on older, outdated hardware. It's kind of like trying to run our super-fast modern internet on the digital version of a 1970s station wagon. It just guzzles gas, or in this case, electricity. And here's another huge source of waste: idle servers. Internet traffic has its peaks and valleys, right? But a ton of servers are just left running at full tilt, even when there's nothing to do. It's basically like leaving every single light on in a huge office building all night long, for no reason. So, that's the problem. It's a big one. But here's the good news. There are some incredibly clever solutions out there. The path to a greener data center really starts by making the servers themselves way smarter. This right here is a total game changer. It's called server virtualization. The basic idea is actually pretty simple, but it's revolutionary. Instead of needing one physical computer for every single task, you can make one single, powerful server act like it's dozens of smaller, separate virtual machines. And the impact is just huge. Instead of having rows and rows of servers that are barely being used, each one sucking up power, you consolidate all of those jobs onto just a few machines that are running at peak efficiency. You're getting way more work done with far less hardware and, you guessed it, a fraction of the electricity. And it goes even deeper than that. We're talking about intelligent power management. Think of it like a three-step process. First, you allocate power dynamically so it only goes where it's needed when it's needed. Second, you put idle servers into low-power sleep modes. And third, you actually cap the maximum energy a server can draw to prevent waste. It's all about being efficient second by second. Okay, so we've made the server smarter. But what about that other massive power drain we talked about, the cooling? This is where the solutions get surprisingly elegant and honestly, pretty cool. Now this is just genius because it's so simple. Instead of trying to blast AC into a giant warehouse, you just manage the airflow. You create dedicated cold aisles that feed cool air right into the front of the servers and hot aisles that capture all the hot air coming out the back. By making sure the hot and cold air never mix, the cooling systems can work smarter, not harder. Smart servers and smart cooling are absolutely huge wins. But the final piece of the puzzle, the real endgame, is to change the power source itself.
The long-term play here is to power these massive facilities with renewables, tapping into solar, wind, and even the Earth's own geothermal energy to create truly green data centers.
So, we have all these amazing solutions, but how do we actually know if they're working? How do you measure success and turn these great ideas into something the entire industry adopts?
Well, it starts with a really simple idea. You can't improve what you don't measure. And in the data center world, the key metric, the magic number, is PUE, which stands for Power Usage Effectiveness. Just think of it like a report card for efficiency. A perfect score is a 1.0. That would mean 100% of the power is going to the computers. The whole industry is in a race to get that number as close to 1.0 as possible.
And that race to 1.0 is guided by a whole team of standards. You've got LEED, which focuses on the building itself being sustainable. You've got Energy Star for the actual IT gear inside. And then you have PUE to measure how efficiently it's all running day to day. It's a multi-front attack on waste, hitting it from every single angle.
And it all really boils down to this one key philosophy. A holistic approach is everything. This isn't a one-and-done fix. Real efficiency is this constant process of monitoring what you're doing, adjusting, and always innovating.
And don't think this is just some theoretical idea on a whiteboard. The biggest names in tech, we're talking Google, Microsoft, Amazon, they're all in on this stuff. They are pioneering these sustainable practices because they've proven that efficiency isn't just good for the planet, it's really good for business too.
So here's the bottom line. We are getting so much smarter and more efficient at powering our digital world. But our appetite for data, it's just exploding. It's growing exponentially. So the fundamental challenge, the real question that's going to define the next chapter of the internet is this: can our quest for efficiency actually keep pace with our demand? That's the race we're all in now.